concept of the time value of money. Some of the great underlying rules of finance are in this chapter. It involves one equation, so it's very, very simple, and just several different little variations on a theme. But if you know math, simple math, you'll be able to calculate all the rest of the equations from this one basic equation. That is the future value equation. Future value equals present value times 1 plus r to the t. And we just want to keep it simple and use it in that format. There are 4 variables in that equation, and we want to just plug the 3 variables into it and solve for the 4th variable, essentially. We want to know the mathematics first. That's critical. So know your mathematics first. Know how to plug the numbers and calculate in a scientific calculator. Then learn how to plug it into a financial calculator where all of these functions are basically built in. So that makes it very, very easy. And then fourth, we want to learn how to type these equations into Excel and solve in Excel, because in your business life, that's what you'll be working in 90% of your day. Off of the future value equation, we come up with a present value equation. What is the value of some future money today? When I use the term present value, we're talking about today. We can also calculate for the rate variable, or the compound annual growth rate, and that is equal to future value over present value to the 1 over tth power, or the tth root, minus 1. And finally, we can solve for time. Time is equal to the natural log of future value over present value divided by natural log of 1 plus r. A very important rule is derived from that rate equation and its approximation. It's called the rule of 72. The rule of 72 is a powerful, powerful concept which you don't need a calculator for. And what it tells you is the rate at which you will have to earn on your money to double your money in a specific period of time, or conversely, the amount of time it takes to double your money at a certain rate. So the equation is rule of 72, t equals 72 over r when I'm trying to calculate for time it takes to double my money, or conversely, percent r equals 72 over t. Basically, you just divide into 72 to calculate to solve for r or t. We have several learning objectives in this chapter, 4 to be specific. First, we're going to talk about future value and compounding, and then present value and discounting, bringing a future sum of money, lump sum of money, back to today. We'll talk about the rule of 72 in some depth, and we'll look at how do we evaluate investments. How can we use this equation, or these 4 or 5 equations, to help us evaluate investments effectively. And we're going to play Who Wants to Be a Millionaire in the process. Future value and compounding. What is future value? The amount an investment is worth after 1 or more time periods, sometime in the future. I always look at in drawing timelines, going out to the right on a timeline versus bringing it back to today, which would be present value discounting. Once again, one equation, future value equals present value times 1 plus r to the t. Again, we're talking, let me overemphasize this, we're talking about a lump sum of money. Not periodic payments of money, but a lump sum of money. Let's look at a couple different banks. If you put $100 into a savings bank, it pays 10% interest per year. How much will you have at the end of 1 year? Essentially, it's very, very simple. You'll have your $100 will grow to $110. So 100 present value times 1 plus r to the first, 1.1 to the first is $110. So it's very, very simple. Now, when I go and leave that money in the bank for more than 1 period, what happens? I start getting interest on the principal. I'll call that simple interest. And then I start getting interest on interest if it's a compound interest bank. So interest on interest is what compound interest is. It's interest earned on reinvestment of previous interest payments. And that's the advantage and the power of compounding, because you're getting interest on principal plus interest on interest. Whereas with simple interest, in a simple interest bank, you're just going to get 10% on that $100 each and every year. So you get $10 every year, 10, 10, 10. Whereas in a compound interest bank, you'll get the 10 of simple interest plus interest on interest in the second year. And that's when things start diverging and the power of compounding kicks in. Here's a great example in a chart of putting that $100 in the bank in simple interest bank and compound interest bank. And in the simple interest bank, as I said, you're going to get $10 a year. So if I leave it in for 5 years, at the end of 5 years in Bank A, which is a simple interest bank, I'll have $150. In Bank B, which is a compound interest bank, I'll have that $10 after the first year, and then another $10 after the second year. And then in the second year, I'm going to get $1 on the first $10 of interest. interest on interest. So in the second year, the simple interest bank and the compound interest bank start diverging, and we get wealthier if we have our money in a compound interest bank. At the end of 5 years, with interest on interest occurring in years 2 through 5, I end up with $161.05, $161.05 versus $150 in total in the simple interest bank. So where do I want to put my money? Simply in the compound interest bank. And that's where I will do the best. Let's go through some illustrative examples. This chapter is loaded with examples of how to apply these concepts. So let's look at, you have a 2-year investment that pays 14%, and you invest $325. How much will you have at the end of 2 years? What is simple interest, and how much is compound interest? So very simply, it is $325 times 1.14 will take us to the end of the first year, and then giving me $370.50, and then taking that $370.50 times 1.14 again, and I end up with $422.37. Alternate way to get that would be to take $325 times 1.14 to the second power, and coming right up with the answer of $422.37. How much is simple interest? P times R times T, 325 times 0.14 times 2, and that gives me $91. And how much is compound interest? Well, all the balance, $6.37 is compound interest. So again, you see, again, if I can get my money into a compound interest environment, I'll do much better. Example 5.2, you have $400 to invest. Investment pays 12%. How much money will you have in 3 years? How much will you have in 7 years? And how much interest will you have earned at the end of 7 years? So let's take a look at that. 3 years, I take 400 times 1.12 to the third, and I get 561.97. And after 7 years, for 7 years, I can do the same thing, and I'll take 400 times 1.12 to the seventh power, in this case, to get 884.27. How much interest will I have earned? I'll take 884.27 minus 400, so I have total interest of 484.27. How much is from compounding? Well, the simple part of that is 400 times 0.12 times 7, and that gives me $336, and the compound interest is the balance, 148.27. So you can see you get very wealthy very quickly if you have your money in a compound interest bank. Here's a really powerful example of time and compounding interest. 1626, Peter Minuit bought Manhattan Island from the Native American Indians for about $24 in goods and trinkets. If I was able to take that money and invest it at the Bank of New York at 10% back in the day, how much would the investment be worth today? And you can see, again, how quickly this money adds up when you leave it in for a large number of years. Time in this case is 384 years. The rate of investment we assume is 10%. And we can see that if I took that $24 and put it in the bank at 10%, 1.1 to the 384th power, it would be worth something like $188 quadrillion. What could we do with this? Well, our authors say you could buy the entire world with that kind of money. So if you have the foresight to put that money away for a long time in a compound interest bank, you can see it piles up very smartly. Another example, example 5.4, Tyco Corporation currently pays a cash dividend of $5 per share. The dividend will be increased by 4% each year. How much will you have in 8 years? Very, very simple. The future value of this dividend will be present value of $5 times 1.04 to the eighth, and I get an answer of $6.84. So you can see how these equations can be used to figure out how quickly your money will multiply or how fast the dividend will grow over a time period. Again, it's compounded on itself. Let's play Who Wants to Be a Millionaire. This is a great little game here. How can you become a millionaire in the United States today? Well, several have suggested you could buy a lottery ticket, maybe start your own business and hit it big, or you can save. You can save to reach a goal. Let's say you have a goal of being a millionaire by the time you're 65 years old and you're currently 21. If you're not 21, just pretend you're 21 for now. And you wish to retire at age 65 and your goal is to have $1 million. You think $1 million will be enough to live on in your 65th year. Again, you should carefully consider that metric, but think about that and think about what your needs will be looking into the future. You can earn 10% per year compounded annually. You can't touch the money, ne touche pas, I like to say in French. So how much do you need to save today in a lump sum to get to your goal. So in this case, we're looking for present value. To fill in our equation, 1 million equals x times 1 plus 0.1 to the 44th power. And the answer to this lump sum question, what is the present value? And the answer is $15,091.13. So what does that say? If I put $15,091.13 in the bank today at age 21 and find a bank that pays, or a mutual fund that pays 10% compounded annually, that shouldn't, if you look at session 12, you'll see that that's not very hard to do. Put it in a good large cap mutual fund with maybe a mix of some small cap stocks and a second mutual fund, and you should be able to get there easily if history repeats itself, because both of those type of investments have exceeded that rate over the past 75 years. Anyway, you'll get $1 million or very, very close to that by the time you're 65. Again, if you don't touch it. If you see at age 40 a Porsche driving down the street and you take some of that money out to buy the Porsche, well, game over. So you must leave that money in the bank and not touch it for 44 years. 15,091.13.